Lagrange multipliers are a method for finding the max or minimum of a multivariable function given a constraint. So it's usually going to be written as del f, or the gradient of f, is equal to lambda, some constant that we're trying to find, times the gradient of g. F and g are functions, and we're taking the gradient. We're also going to say that the g function is going to be equal to some constant. So it could be, say, a sphere, but then we're going to say it's equal to some radius value like x squared plus y squared plus, say, z squared is equal to 1 or 2 or 3 or k. That's essentially what we would be doing with that. So once we find these constraints, we evaluate f at all points of interest. The largest would be like the maximum, the smallest would be the minimum, obviously. So I'll do an example. Let's say f of x, y, z is equal to 3x plus 7y plus 2z. Given the constraint g of x is equal to x squared plus y squared plus z squared is equal to 1. So now we take the gradient of f, 3, 7, 2, and then for g, 2x, 2y, comma 2z. Now, when we take our Lagrange multiplier equation, we say, okay, well, 3 is equal to lambda 2x, 7 is equal to lambda 2y, and 2 is equal to lambda 2z. We are then going to solve for x, y, and z. So we got 3 over 2 lambda is equal to x, 7 over 2 lambda is equal to y, z is equal to 1 over lambda. We plug these values into our constraint equation. So we get x squared, 3 over 2 lambda squared plus 7 over 2 lambda squared plus 1 over lambda squared is equal to 1. Now we just do a little bit of arithmetic. 9 over 4 lambda squared plus 9 over 4 lambda squared plus and this is almost ready, but we have to combine this, so just multiply this by 4 over 4. And then we have 9 plus 49 plus 4, which would give us 62 over 4 lambda squared is equal to 1. And we just solve for lambda. Four lambda squared is equal to 62. Lambda squared is 62 over 4. 31 halves. And then we can take the square root. So lambda is equal to the square root of 31 over 2. So now we know our value for lambda. We can plug that back into our values of x, y, and z. So up here, this was our constraint equation, so I'll rewrite it again down here. I'm also going to rewrite lambda as the square root of 62 over 4, or the square root of 62 divided by 2, because it makes some of them look a lot nicer because we had the 2 lambda. So x was 3 over 2 lambda, and this gives us 3 over 2 times 2 over root 62 is 3 over root 62. And this is plus or minus. Oh, that does not look good. Y was 7 over 2 lambda, and this gives us 7 over root 62. And z is just 2 over plus or minus root 62. So now we can take the function values of these. Because of how this problem is worded, we have f is equal to 3x plus 7y plus 2z. Because of how this is made, there's only going to be really 2 points. We don't have to plug in plus the positive version of this with the negative version of that and the positive version of that. We only have to look at the positive and the negative. So f of, let's x, y, z, and f of negative x, negative y, negative z. And they're going to be totally opposite, well, negative of each other. When we take the, let's take f of x, y, z, 3 times 3 over root 62 plus 7 times 7 over root 62 plus 2 times 2 over root 62. And all of this comes up to 62 over root 62. Which, when you radicalize the denominator, you take away that radical, you get 62 root 62 over 62, or just root 62. And that would be the maximum value of this function given this constraint. When we take the negative of this, it's just going to be negative root 62, and that would be the minimum value. This was just a simple demonstration problem. Others may include more advanced techniques, like maybe making a matrix or other sorts of problem solving techniques. But this is the basics for Lagrange multipliers. We get del f, the gradient of f is equal to the lambda times the gradient of g. We're setting the function of g is equal to a constant. So we just take the gradient of f, the gradient of g, set them equal to each other with some parameter lambda, and plug that in, find lambda, plug that back in, find our function values, and then we get our min and max given the constraint of the function. Thanks for watching.